the air purifying system using water or mixed liquid. Principles. 1. Put centrifuge force, which is produced by rotating axis to liquid or liquid mixture. 2. Put air to the arbitrary direction. 3. Make chambers inside of outer column using curtains. 4. Mix air and liquid or liquid mixture at the inside of chambers. 5. Pass mixing air to space between rotating curtain and outer column where established liquid column produced by centrifuge force caused by rotating axis. 6. Contain liquid or liquid mixture in outer column and air in inner column. Applications, replacing of the principles of exiting air filter. These principles can be applied for the living space of human beings such as inside room air cleaner for housing, apartment, commercial building, and drink bar, air conditioner, motor fan, vacuum cleaner, inside of car, harmful gas emitting vehicle, air smoke pollution factory, waste garbage trash burner, thermoelectric power plant, environmental glass, personal potable air purifier, vac system in building, inside of subway station, airplane, submarine, etc. Detailed description of the invention. A device of the invention includes an air inlet structure for taking in contaminated air, an air purifying compartment connected to the air inlet structure at one end for purifying contaminated air, and an air outlet structure connected to the air purifying compartment at another end for discharging purified air to the outside. An inventive device purifies air using a liquid filter which is formed when the air purifying compartment rotates. An invented device further includes an outer case located outside the air purifying compartment to protect the air purifying compartment that rotates at a high speed and a bearing that supports and allows the air purifying compartment to rotate. An invented device also includes a motor that is coupled to the air purifying compartment to enable the air purifying compartment to rotate around the rotational axis. The invention further utilizes mixed liquid to purify air. The filling holes are placed at suitable locations on the outer surface of the air purifying compartment to allow treatment liquid to be poured into the air purifying compartment. The discharge holes are also placed at suitable locations on the outer surface of the air purifying compartment to allow the treatment liquid to be dispensed out of the air purifying compartment. It is also recommended that projecting rings having an appropriate fixed height are placed on an inner structure and project outwardly along a radial direction from the inner structure, and that the projecting rings are placed inside the air purifying compartment. The mixed liquid filter is formed by centrifugal force produced by the rotation of the air purifying compartment coupled to a motor. The invention further provides a method of taking in air. An impeller which is at the air outlet structure creates a pressure difference which causes contaminated air created by a contaminant to move into a contaminated air transfer chamber, a contaminated air inlet, and a contaminated air inlet passageway to reach the air purifying compartment. The invention also provides a method of purifying air in which the contaminated air that was transferred into the air purifying compartment using the aforementioned method of taking in air moves into a purifying chamber through inlet holes. The purifying chamber is in one of the air purifying stages that form the air purifying compartment. The contaminated air is purified when it comes into contact with the mixed liquid filter. The invention further provides a method of discharging purified air. The purified air that exits outlet holes of a purifying stage passes through a purified air outlet passageway, a purified air outlet, and the impeller. The purified air then finally reaches the final outlet to be discharged to the outside world. The tests were performed on automobile exhaust gas. The purifying system of the invention used in this test had an air purifying compartment that included only a single purifying stage that had 3 projecting rings. It included other components that are similar to those previously described. The mixed liquid used in this test included NO, FeSO4, and H2O, while the existing air purifying system reduced the level of hydrocarbon to 110 ppm and the level of carbon monoxide to 0.6%. The single-stage system of the invention reduced the level of hydrocarbon to 10 ppm and the level of carbon monoxide to 0.1%. Particularly, while the existing system reduced the amount of dust to 30%, the single-stage system of the invention rapidly reduced the amount of dust to 2%. Although an invented air purifying system having multiple purifying stages is shown and described as one example in the overall description of this invention, the invented purifying system is able to include any number of purifying stages depending on, among others, the amount of contaminated air and the constituents of contaminated air. In addition, to increase the efficiency of the air purification process, it is possible to use multiple purifying stages and liquids for each constituent of the contaminated air. Other variations are also possible, including a single purifying stage system as described above with respect to the test conducted in which a single purifying stage having mixed liquid is used to treat various contamination constituents. While the invention has been particularly described with reference to certain examples, one having ordinary skill in the art would know that there may be many other ways to implement the invention without departing from the spree and scope of the invention. Many changes and modifications may be made to the invention without departing from the spree and scope of the invention.